Hello there. I hope you're staying healthy and enjoying learning a little bit of physics in the comfort of your own home. I wanted to just help you out here with learning how to draw a number line diagram. We're going to use question number 11 to focus on that. So a number line diagram is just a way of organizing all the information that you see about the motion of an object. So when you read number 11, it says there's a car that starts 2 times 10 to the second meters west. So that's 200 meters west of a town square, moves with a constant velocity of 15 meters per second toward the east. Choose a coordinate system in which the x-axis points east and the origin is at the town square. So if we draw that, I'm just drawing a line here that represents an x-axis. It says that east is it points east, which means east is the positive direction. So I'll put an E here and a positive. And so over here would be west, and that's the negative direction. It says the origin is the town square. Origin means position 0. The important information for us is where the car starts, 200 meters west of the town square. So west would be over here. And so the important thing is we would call that negative 200. If you think about an x-axis, this is on the negative side of the x-axis. And it's really important that we make the initial position of that car negative 200. Maybe a little list here. The first part of a number line diagram, we'll be doing more of those in the future. Number line diagram is draw the number line. And of course, mark any important positions on the number line. Step number 2 is to draw any given or important velocities. So we know the car starts here. Sometimes I like to draw a little object, little picture that represents the object. And it says the car has a constant velocity, 15 meters per second, and this is really important, toward the east. So I want to draw an arrow. Velocity is a vector. It points to the east. Anything that points to the east, that's the positive direction, is positive. So this is a positive 15 meter per second velocity. And it's really important to notice that an object can have a negative position. It's in the negative numbers on the position axis, but it's moving to the right, so it has a positive velocity. So we're going to draw an arrow that represents velocity. Now, in the future, we'll be drawing acceleration too, but we don't have any acceleration in this situation. So that's really all I wanted to show you. I think that drawing this will help you to do part A here, write the equation that represents the motion of the car. When you get to question number 12 and it says draw a graph showing the motion of both the car and the truck, really the first thing you should do, it doesn't ask you to do it. You're going to need to you're going to need to write a position equation for the truck in order to make that graph. So try to draw what's going on with the truck on the same number line. So they give you information about the truck's motion up here. Draw that in on this number line, and that should help you to make the equation for the truck. So that's the main thing I wanted to show you. Maybe since I'm here and you're here, one other little comment. I don't know if you had any trouble with number 9, where you had to write the equation that represents the motion. And of course, the equation we're using is x equals vt plus x0, initial position. So the v is the velocity. And just remember that velocity is the slope of this graph. So car A starts here, car A or bicycle A stops there. The coordinate there, the x coordinate is 0.8 and the y coordinate is 6 over here. This point here, the x coordinate is 0 and the y coordinate is -3. Remember that slope is y2 minus y1 over x2 minus x1, and you should be able to get that. Okay, good luck with that. You can always stop in for office hours if you have any questions, and stay healthy.